morning friends. Today we also consider the more numerical asked in Neet exam. Now 26 number question. Two identical thin plano convex planes of effective index 1.5 each having the radius of curvature of 20 centimeter are placed with their convex surfaces in contact at the center. Whatever the remaining space between the two lenses is filled with a oil of effective index 1.7. The focal length of the combination is. Now first we try to understand what is the situation. Two plano convex lenses are given like this way. One plano convex lens, second plano convex lens is like this manner. Same radius of curvature. Both are placed in such a way that their curvature surfaces is in contact at the center. Okay. Now, whatever this space, in this space, here the oil is filled. There is the oil. Having the effective index is 1.7. Now the both lenses made from the glass. So actually here the combination of the three lenses. One lens is this plano convex lens. Second is oil. Because this part forms the concave lens. There is the second. And third lens is again the plano convex lens, this third. We require the resultant focal length of this combination. So by using the lens maker's equation, first we find out the focal length of these three lenses. And resultant focal length of this combination 1 upon f is equal to 1 upon f1 plus 1 upon f2 plus 1 upon f3. For that purpose here, you have lens maker's equation. Lens maker's equation 1 upon f is equal to n minus 1 into 1 upon r1 minus 1 upon r. For lens 1, this lens. Now listen, there is the second curved surface having the effective, having the radius of curvature. There is the minus r2. R is given. There is the 20 centimeter. There is the 20 centimeter radius of curvature. But first surface of this lens is plane, therefore R1 is infinite. R1 is infinite. Therefore 1 upon F1 is equal to effective index of this glass lens is 1.5. So 1.5 minus 1. 1.5 minus 1. Well, we had first the equation for this. So 1 upon f1 is equal to ng glass lens minus 1 upon infinite minus 1 upon r. Minus 1 upon r. Clear this? Okay. For that purpose here, we can add ng 1.5 given minus 1 here. 1 upon infinite 0 minus. This radius of curvature is negative, therefore there is again minus 1 upon 20. So its simplification is 1 by 4. So that is the 1 upon f. For oil material or the oil surface, focal length is 1 upon f2 is equal to NO oil minus 1 upon R1 minus 1 upon R. There is a concave surface is formed. Concave surface has one is radius of curvature is negative while this side is positive. Where is 4? Therefore, it is substituted its value 1.7 minus 1. Here 1 upon 20 first minus 1 upon 20. And for second that becomes the positive because this surface is positive, radius of curvature. For this surface the radius of curvature is negative. Therefore its simplification is minus 7 upon 100. That is our lens 2. For lens 3, 1 upon f3 is equal to again ng minus 1 for this lens. This radius of curvature is r1 while the r2 is infinite. Therefore 1 upon r1 minus 1 upon infinite is equal to 1.5 minus 1 upon 20 minus 1 minus 0 1 upon infinite. So its simplification is 1 by 40. 1 by 40. Therefore, the equivalent focal length of combination is 1 upon f is equal to 1 upon f1 plus 1 upon f2 plus 1 upon f3. If we substitute the value 1 by 40 minus 7 by 100 plus 1 by 40. So its answer is minus 50. Therefore, f is equal to minus 50 centimeter. That is our answer. Here is actually very easy. Without doing the figure, we don't understand it. Here the two plano-convex lines of radius of curvature 20 centimeter and effective index 1.5 are placed with their convex surfaces in contact at the center. Right? Now, what is the part remaining without contact? So in this we fill the oil. Therefore, this oil part forms the concave here, this. So this lens is made up of a oil. So here that means here the combination of the three lenses. One is plano-convex, second is concave, made from the oil, and third is again the plano-convex lens of glass. So we require the equivalent focal length of this combination. Therefore, first separately we have to find out the focal length of each lens. By using lens maker's equation, 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon r2. First and third made up of a glass, therefore we consider Ng. Effective index of a glass is 1.5 and for oil is given as 1.7. Areas of curvature are given 20 centimeter. So this way we find out the resultant focal length of this combination. Clear this? Okay. Now after that the next, the effective angle of a prism is given A and effective index of a material of a prism is cot A by 2. The angle of minimum deviation is what? Therefore we know that for a prism, effective index n is equal to sine A plus delta m by 2 upon sine A by 2. But here, effective index is given in that form, cot A by 2. Therefore, cot A by 2 is equal to this sine A plus delta m by 2 upon sine A by 2. Cos upon sine, therefore cos A by 2 upon sine A by 2 is equal to sine A plus delta m by 2 upon sine A by 2. So this term is cancelled, denominator term. Therefore, remaining part is cos A by 2 is equal to sin A plus delta M by 2. Now convert the cos into the sine. Convert the cos into sine. So I can write like this: sine 90 minus A by 2 is equal to sine A plus delta M by 2. Sine cancel. Therefore, 90 minus A by 2 is equal to A plus delta M by 2. On left hand side, we take the 2 LCM. These two to cancel. Therefore, 180 minus A is equal to A plus delta M. We require the delta M minimum deviation is equal to 180 minus 2A. That is our answer. Again, using the equation of effect index of material of the prism, N is equal to sin A plus delta M by 2 upon sin A by 2. N is the effect index that is given in terms of the cot A by 2. Therefore, cot A by 2 is equal to sin A plus delta M by 2 upon sin A by 2. Cot, cos upon sin, cos A by 2 upon sin A by 2 is equal to sin A plus delta M by 2 upon sin A by 2. Sin A by 2, sin A by 2 cancel. Therefore, remaining part is cos A by 2 is equal to sin A plus delta M by 2. Therefore, convert the cos into sin because on the right hand side the sin function. Therefore, sin 90 minus A by 2 is equal to sin A plus delta M by 2. Sin cancel. 90 minus A by 2 is equal to A plus delta M whole by 2. Okay. On left hand side, we take the LCM 2. Therefore, 180 minus A upon 2 is equal to A plus delta M by 2. 2 to cancel. Therefore, 180 minus A is equal to A plus delta M. We require the angle of minimum deviation. Therefore, delta M is equal to, take A on LHS. Therefore, 180 minus 2A. Clear? Only the mathematical simplification to get the answer. Now, third. In an astronomical telescope in normal adjustment, a straight black line of length L is drawn on inside part of an objective lens. Now, first, in a telescope, there is the objective lens. One black line of length L is drawn inside the telescope on objective lens. The eyepiece forms a real image of this line. The length of this image line is I. The magnification of telescope is O. Now that is the eyepiece. The image is formatted here of length I. Is it formatted FE distance? Total distance is, that means the total distance between objective and eyepiece is FO plus FE. That is objective. That is eyepiece. Clear this? Okay. Now in that case, the magnification of this telescope we have to find out. First thing, the magnification of telescope is FO upon FE. Magnification of a telescope is FO upon FE. But we know that magnification M is equal to V upon U. V upon U is equal to minus I upon L. That means the height of an image to the height of an object. but magnification M is equal to V upon U is equal to height of image to the height of object. Height of object. Therefore, V upon U is equal to minus I upon L. But from figure, what is the I? I is equal to, now listen, V. V is equal to AP. Image distance. Object distance is AP minus FO plus AP. Because here AP is positive U. Object distance is negative. Object distance is this FO plus AP. Now we simplify it. So we obtain AP upon FO, and that is the negative. So this side negative, this side negative. So from this equation, FO upon FP is equal to L upon I. L upon I. So this is our answer. Again here, one black line of length L is drawn on objective inside the telescope. Okay. So that is our object. Line of length L is our object. The image of this line is formed by the eyepiece of length I. So eyepiece having the focal length is AP. Therefore, in case of a telescope, the image is formed at focal length or the focal point of an eyepiece. That means at AP distance. So there is our V. There is our V. Now there is our object distance because the object, that means the black line of length L is at FO plus AP distance. And what are the distance from the image? So AP minus FO plus AP. Okay. Now, so magnification of a telescope is FO upon AP, and we also know that magnification of a lens is magnitude of V upon U is equal to height of image upon height of an object. Therefore, V upon U is equal to minus I upon L. Now, V, that means the image distance is AP, object distance is AP minus FO plus AP. Therefore, minus AP upon FO is equal to minus I upon L. Take the inverse, therefore FO upon AP is equal to L upon I. So that is our answer. That is the magnification of astronomical telescope. Clear it? Okay. Now the next numerical, asked in 2015 in All India PMT, a beam of light consisting of the three colors red, green and blue is incident on a right angle prism. The effective index of material of a prism for red, green and blue wavelength are 1.39, 1.44 and 1.47 respectively. Now, for this condition, what should be the answer? The prism will first separate the red color part from the green and blue color. Right. Second option, separate the blue color part from the red and green color. Third is separate all the three colors from one another. And option D, not separate the three colors at all. So out of these four sentences, which is right? First we do the diagram. Here the right angle prism is given. On this right angle prism, here the three colors red, green and blue are incident on a prism. That is the red, that is green, and that is the blue. Incident on a right angle prism. Therefore, the angle of incidence this angle is 45 degrees. Effective index of material of a prism for a given color NR, for a red color NR is first thing. First is given for the head 1.39. Next is NG in green is 1.44, and NP is equal to 1.47. These are the effective indices of a prism for wavelength of red, green, and blue light. Now, from total internal reflection, we are using the condition N is equal to 1 upon sin C. 1 upon sin C. Therefore, 1 upon sin 45. Therefore, N is equal to root 2. Therefore, N is equal to 1.414. So, 1.414 is less than for red color. For red, NR is less than N. Right? For green, NG 1.44, which is greater than our finding effective index, NG. NG is greater than N. And N blue is also greater than N. Therefore, red color is separated from green and blue. Because the red color is not suffer the total internal reflection. Only red is do not total internal reflection. Not get total internal reflection. Therefore, the red color is separate from the blue and green color. So when these three colors are passed, at that time the green and blue suffers the total internal reflection. While for the red, here the effective index of material of a prism is greater than the effective index for the red color. Therefore, red color is not suffers the total internal reflection, while the blue and green suffers the total internal reflection. Therefore, red color is separated from blue and green color. Okay. Now, next question is depends on the theory base and also the knowledge base for mirror. Now, make the corresponding entries of column 1 with column 2, where the aim is the magnification produced by the mirror. First is magnification is given -2, so convex mirror. M is equal to -1/2 concave mirror. M is equal to +2, C option is real image. M is equal to +half virtual image. Now listen, magnification is negative, that means the image is inverted image. Inverted image. Magnification is positive, that means which type of the image? React image is obtained. Okay. Now listen. Out of these four options are given 1. That means M is equal to -2 for A and C. A is the convex mirror, C is the real image. Right? So these the options are given according to our knowledge of how the image produced by the mirror and which type of the image, and for given type of the image what should be the magnification. We have to match it. So option D is right, 1 is B and C. Here the M is -2, that means for the concave mirror, and real image is obtained because the real and inverted. Now B and C, B and D, A and B. M is equal to -1/2, again concave mirror and real image. M is equal to +2, so that is the B and D, concave mirror and virtual image. And also A and D, convex mirror and virtual image. Clear this? So this type of the table already we learned in 10th standard. right? Which type of the image is formed by the given image. Okay. Now next, the angle of incidence for a ray of light at a reflecting surface of a prism is 45 degrees. Clear? The angle of prism is 60. Angle of prism is given as 60. Okay. If the ray suffers the minimum deviation through the prism, the angle of minimum deviation and refractive index of material of a prism, we have to find out. We have to find out the delta M and A for a given prism. Now, what this numerical suggests, that is, prism is given. There is the A, B, and C. Now listen, there is the perpendicular on AB and AC surface. Now the ray incident at 45 degree angle. There is the P. It suffers the refraction. Suffers the refraction. And again incident on AC surface. So here this angle is 30 degree. So incident at 30 degree again angle. And refracted or the immerse at 45 degree. Immerse at 45 degree. So angle of incidence 45, angle of deviation, angle of immersion is 30. Here at 30 degree that is the incident, at 45 degree angle of emergence, that is the coming out from the prism. So we know that I plus E is equal to A plus delta. I plus E is equal to A plus delta. But I is equal to E is equal to 45. A is 60. Therefore, 45 plus 45 is equal to 60 plus delta M. Therefore, 90 is equal to 60 plus delta. Therefore, delta is equal to 30 degree. Delta is equal to 30 degree. Thus, we find out the minimum deviation for this given angle. For this given prism. Now we require the effective index. So, using the equation n is equal to sin A plus delta M by 2 upon sin A by 2. Now listen, we have the value A 60, delta and we find out the 30. 60 plus 30, 90 by 2, 45 upon sin 30. So it's equal to sin 45 upon sin 30. Sin 45, 1 upon root 2. And sin 30, 1 by 2, that means the 2 is equal to root 2, that means 1.414. Okay, that is given in terms of the root 2. Therefore, the effective index of material of the prism is root 2. So 30 degree root 2 is the answer. Again, the question is that the angle of incidence for a ray of light at a reflecting surface of prism is 45. So I is given the 45 degree. The angle of prism is 60. If the ray suffers the minimum deviation through the prism, the angle of minimum deviation and effective index we have to find out. Here there is given the ray suffers the minimum deviation. That means for minimum deviation condition I is equal to E, and we have the equation I plus E is equal to A plus delta. Right? For delta is equal to delta M, I is equal to E, and that is given 45. So 45 plus 45, 90. Prism angle 60 plus delta. Therefore, delta is equal to 30. That is the value of minimum deviation. Now we also want to find out the effective index of material of a prism. So n is equal to sin A plus delta M by 2 upon sin A by 2. A is no one. Now delta M is also no one. Delta M is also no one. Delta M is 30. A is equal to 60. 30 plus 60 by 2, 90 by 2, sin 45. Upon sin 60 by 2, sin 30. Sin 30, 1 by 2. Sine 45, 1 upon root 2, divided by 1 by 2. 2 is in denominator of denominator, comes into the numerator. Therefore, 1 upon root 2 into 2. Therefore, only root 2. Clear?